All right. Now, this is how I learned the quotient rule. So this is how we write it. It's low, D high. You like that? Low. D high minus, I wrote too big. I already wrote too big. I need to erase this and start over. Maybe if I write LO and HI, I'm going to write that. LO, low, D high, minus high, D low. That seems a little bit more, I don't know, Seven Dwarfs anyway. Low D high minus high D low divided by low squared. That's what it is. Low D high minus high D low divided by low squared is the easiest way for students to remember it when they're first learning it. Low D high minus high D low divided by low squared. Okay, for this one, the way that I remember it is the first times the derivative of the second plus the second times the derivative of the first. That's how I remember that one. First times the derivative of the second plus the second times the derivative of the first. Some people do it backwards. They do the second times the derivative of the first plus the first times the derivative of the second. And whenever they ask me to check their work, my brain cannot handle it. I cannot. I'll figure out, I'll be like, okay, they're one of those. They're one of those people. And then I cannot for the life of me. I'm like, hold on. Put your paper down. I gotta write this and figure out it's all backward. The signs are all wrong. Like, it truly messes my brain up. So if you want to torture me, if you get mad at me and you ever like are like, I want to ruin Miss Rice's day, do it backwards and ask me to check your answer for you. Okay? If you're just mad at me and you feel like that's the right way to go about it. Okay? All right, so which one do we want to do? We don't care. We just want to do one of them. We can do 9. Let's do 9. I never have blank paper when I need it, and to reach past my HDMI cord. It's so fun. HDMI cord? No. That's true. I put it over here because it's more convenient for kids to get to. It's mostly for kids. It's supposed to be all for kids except my paper's back there. Also, my paper's more expensive because I get the reinforced hole punch part. But this paper I'm just going to recycle, so I use the cheap paper for random examples. All right, so this is Larson, page 146, number 9. We have h of x is x to the 1/2 divided by x to the 3rd plus 1. All right. So this is the funniest thing. My document camera has a remote control, which cracks me up because you use your document camera when it's literally 2 inches from you. But I thought maybe the zoom would work better with the remote control. And it does. Have you guys ever watched me struggle with the zoom? It just like does not zoom when it's supposed to. So I was like, maybe the remote control is better. So that tells you that the button on here is just bad. Perfect. Now I can zoom apparently with my remote control. Look like a lazy American. All right, so we're going to do h prime of x. We're going to do our formula. Low d high. Low d high. Okay, what's the derivative of the top? 1/2 x to the negative 1/2. Okay. minus high d low x to the 1/2. And then what's the derivative of the bottom? 3x squared. Do we need to put the plus 0 for now, or are we okay with just not putting anything? We're okay with that? Okay. Low d high minus high d low. Divided by low squared. Yeah, isn't that funsies? My headaches are like impressive. They just like really hang on. I woke up this morning with a really bad headache. It could have been that I just didn't sleep long enough because my cat at 4:30 was like, "Mama, it's time! It's time to go outside!" And I was like, "No, it's not. It is not." And then I let him outside, and the neighbor cat was like, "Time for breakfast?" And the neighbor cat came inside the house, but he was polite about it. He just, the cat door was open, but he sat outside the door screaming until I opened the cat. I literally squatted down and pushed open the door for him and said, "Come inside." And he said, "Okay." And then he came inside. And then I was like laying on the couch in the dark trying to sleep, and the neighbor cat was like squeaking at me because I normally pet him a lot. He's like, "Morning, pets? No? You still sleeping? 5 a.m. Not good time?" So I had a headache this morning. The cats may or may not have been part of the equation. We're not sure, but they did not help. That's for sure. So they got to go outside. They got their morning snacks, and then I passed out about the time my alarm went off to get up. So good times, And now I'm doing calculus, which we know helps headaches, makes them feel real good. So, all right, what do we do now? Yeah, we distribute that. So the coefficient is just going to be the coefficient. What do we do with the exponents? You add them, yeah. So 3 plus a -1/2 is 2.5, which is 5/2. Okay. 1/2 times 1 is just 1/2, and x to the -1/2. Okay. And then we got minus, and then what do we get for this part? 5/2. Because it's a positive 1/2 that time. Yeah. All right. Mm-hmm.
Could we have separated it and canceled the 3x cubed plus 1?
Like canceled this with this?
Well, no, like separated it, so like 3x cubed plus 1 times the 1/2, and then over the 3x.
So if you separated it, then you'd have like a fraction and another fraction, and a lot of times in simplifying you want to get a common denominator if you have two fractions. So that's one of the parts of calculus that is a little bit like subjective, I'd say, in simplifying is canceling normally part of simplifying? Yes. Is getting a common denominator part of simplifying normally? Yes. Our answer is going to look complicated no matter what. So at this point, like lots of answers apply. So this is one where if we were doing a multiple choice problem, all the answers would be acceptable. We do want to make sure that we're comfortable with manipulating things like this because a multiple choice answer could have lots of different forms, and we want to make sure that we can get to one of those forms and that we can recognize if our answer is just a variation of a multiple choice answer. Yeah. Okay. What do you guys see? So I see like these two. We got some like terms there, right? So what coefficient should we have with those like terms? Yeah, -5/2. Okay. And then I also can see, actually I'm not going to write it like that. X to the 5/2, okay, plus 1/2 x to the -1/2. Okay, so it's possible that they'd be like, yep, you're good. That's the final answer. It's possible. In an FRQ, absolutely, yep, you're done. Okay. All right, let's use some of our strategies from the summer assignment to get rid of maybe some of the fraction stuff that's going on here. So how could we get rid of the 2 on the bottom of these fractions? Yeah, so what we could do is we could say, let's multiply by 2 over 2, right? So that's going to get rid of the fractions, okay? So that's going to fix things a little bit. What does that do to the top? -5x to the 5/2. Yep. Yep, that's right. Oh, sorry, you can't see what I'm writing. I'm so zoomed in. Let me zoom out just a little bit. I feel so bougie when let me zoom out and I pick up my remote. Okay, so -5 x to the 5/2. Okay, what else do I have? Okay, plus, and then what's this part going to be? But not 2. 1. Okay, so plus x to the -1/2. What do I have on the bottom? Okay. That already looks better, doesn't it? Okay. All right. So we've got this negative exponent happening here. So they probably would not, a multiple choice problem might not leave it like that. So I'm going to rewrite this and then we're going to think about how we could fix it, okay? So I'm going to think of this as -5 x to the 5/2 plus 1 over x to the 1/2. Okay. You can't just move it to the bottom because this plus right here makes that not possible. If it had been a multiply problem on top, then we could have just moved it to the bottom, but because of that plus, you can't. So we're going to have to multiply this by something, just like we did to get rid of the 2's. We're going to have to multiply by something, and what could we multiply? Yeah, we could multiply by x to the 1/2. Okay. So again, I have to make sure I do that to both things. All right, so for that first term, now be careful with that first term. What is that going to do there? Yeah, -5x to the 3rd, because it actually makes it -5x to the 6/2, right? 5/2 and another half gives you 6/2. And that makes it 5x to the 3rd, okay. Plus, and then what does it do to this one? Makes it a 1, okay. And then what does it do to the bottom? Yeah, 2x to the 1/2, x to the 3rd plus 1 squared, okay. So, on an FRQ, that first answer is fine. That first answer is totally good. We did the quotient rule, we combined like terms, and we were done. FRQ, that's fine. Would that answer have been there for a multiple choice problem? I don't know. So we just practice what we've learned about getting rid of some. This was a complex fraction when we had the halves and the 1/2. So we took what we learned about getting rid of complex fractions, and then we fixed our negative exponent in a mathematically legal way. That's all we did. This feels a little bit cleaner, looks a little bit nicer. They're mathematically equivalent though. So really it's about when you get down to a multiple choice problem, recognizing just because my answer's not there doesn't mean I did it wrong. It might just mean that I haven't simplified it the way they wanted me to. Does that make sense? Okay. Should we do a different quotient rule problem or a product rule problem? How did you guys feel about the other problems that were on the homework assignment? They're okay? They're good? Okay. Yeah. Let's look at number 8. So this is page 146, number 8. Number 8 was easier than number 9. 3t squared minus 1, 2t plus 5. Well, number 9 was hard because of the x to the 1/2. Yeah, so that introduced fractions into the problem, it introduced negative exponents into the problem, it introduced a lot. So this one is quite a bit easier. Okay, so let's walk through that derivative. What should I write first? Okay, so low, and then what comes next? Okay, low d high minus high, okay, what next? D low divided by low squared, okay? And then we'll go ahead and just clean it up. So 6t distributed gives you what? 12t squared plus 30t, okay? And then what do we have next? Okay? Minus 2, yeah. And you can do your you can distribute your negative and distribute your 2 at the same time if you are really good with not making little mistakes. If you're bad about making little mistakes, then take up paper, take up time, and do little steps. Does that make sense? Because in calculus, this is convoluted math, right? Not necessarily lots of, we already did the hardest part, the low d high minus high d low divided by low squared. That was the hardest part. The rest of it, the just cleaning it up part, lots of room for error, right? So if you think that you could make little mistakes, just show your work, take up space, take a little bit of extra time to make sure that you're being careful. All right. Because I cannot tell you how many times on an FRQ I've graded it and a student missed a negative and I had to mark them wrong for the final answer. And FRQs are only worth 9 points. So it's like you did all that work to miss a negative and then not even get any partial credit for that because when they grade FRQs, they just do like right or wrong for that answer point. So you just want to be careful. All right, what do we do next? So 6t squared plus 30t plus 2. If you look at that, and you have a feeling that one of the factors might be 2t plus 5, you can try to factor it. If you do not feel like one of the factors is going to be 2t plus 5, don't waste your time. Because the third term is 2, if you were to factor it, then this number and this number are going to have to multiply to be 2. These two numbers over here are going to have to multiply to be 2. Neither one of those is going to be a 5. That means that no matter what I factor this to be, it is not going to simplify with the bottom. It means I'm done. I don't care if the top is factorable, it's not going to cancel, it's not worth my time. Does that make sense? So whatever the top, it's definitely got a GCF of 2. Once I take out the GCF of 2, it's possible it might be factorable, but no matter what, it's not going to cancel out with that 5 on the end. So factoring it is not worth my time. Okay? So I'm done. That's it. Don't you dare try to cancel out these 2's. You kill a puppy if you do that. We don't kill puppies in this room, okay? We keep them alive. We keep them alive. If you kill a puppy, I'm going to notice. I'm going to make you put a little tally on the wall of shame, the corner of shame. All right, I might announce it. make you do it in front of everyone. Okay? Okay. All right. Sound good? Good? Okay. How'd you guys feel about the notes last night? Tangent lines, normal lines. Okay. Today's assignments is one of my favorites. All right. Let's go ahead and get started together. So, we are trying to figure out the seating chart of the class. Okay? It says, all students are located at integral coordinates in the xy plane, so they're not located at decimals, it's all whole numbers. On the set -2, -1, 0, 1, and 2, so that's the x coordinates, -2, -1, 0, 1, and 2, so that's all the x coordinates you can see. The y coordinates are from -1 up to 3, okay? So this is like an xy plane. Abel is seated on the line, which is normal to the curve f of x equals x squared minus 2x plus 4 at the point 1, 3. Okay, we're about to get started. So we're starting at number 2. Abel. Okay. All right, we got f of x is x squared minus 2x plus 4. We got the point 1, 3, okay? So it says the line that is normal to that curve. So before we even find the normal line, we still got to find the derivative. Okay, what's the derivative for this? Okay. And what's the slope going to be at x equals 1? So 2 times 1 minus 2 equals 0. Okay, so the slope at 1, so the tangent line has a slope of 0. So the tangent line is horizontal. Would you agree?
Yeah.
Okay, so this tells us the tangent is horizontal. And so what does that mean for the normal line? Normal line is vertical. Okay, so tangent line is horizontal and goes through the point 1, 3. Normal line is vertical and goes through the point 1, 3. So what is the equation of the vertical line that goes through the point 1, 3? Ooh, we rusty. X equals 1. The horizontal line that goes through 1, 3 is y equals 3. So horizontal lines are y equals a number. Vertical lines are x equals a number. Okay. So no y equals mx plus b, no using the point slope formula. Whenever you have a straight horizontal line, a straight vertical line, it's just x equals a number, y equals a number. So as soon as we figured out, oh, the tangent line had a slope of 0, that's just y equals a number. Y equals the y coordinate of the point you went through. So slope of 0, the tangent line, y equals 3. The normal line to that, the line that's perpendicular to that, is the vertical line. X equals a number, and it's got to be the x coordinate that you went through. So Abel is somewhere at one of these seats. Abel is somewhere at one of these seats. Does that make sense? Abel is at 1, -1, 1, 0, 1, 1, 1, 2, 1, 3. So let's flip the page over. Abel is at 1, -1, 1, 0, 1, 1, 1, 2, 1, 3. Somewhere along the line, x equals 1. Those are the possibilities. Yes?
Why can't you say that one?
Because it's the line that is normal to the curve and it goes through the point, but it doesn't say he's seated there. It says he's on that line. Did it say he was seated there?
No, it didn't say it, but then, can you explain how you found the first part?
Okay, so it says Abel is seated on the line, which is normal to this curve at that point.
Okay.
You have to find the tangent line because normal lines are perpendicular to tangent lines. So I found the tangent line first, and then I figured out what was perpendicular to it. Yep, because derivative gives you tangent. Yeah, this was kind of a weird one. That's why we did it together. Okay, let's do another one. Make sure we're good. Magupta. Why are you laughing at my son? These are mathematician names. You'll recognize some of them later on. It's on the line normal to the curve, but y equals x to the fifth minus x to the fourth plus 1 at x equals 1. Okay, so what do we need to do? It's the same situation, right? It said normal again, so we already know the process. Let's go ahead and do the process. So they gave us the curve, and we need to find derivative. So y prime is 5x to the fourth. I thought you said squared for some reason. Minus, sorry, you're like, that was a trick? That was a trick? Minus 4x to the third, okay. And what are we going to do from there? Plug in the 1. Y of 1 is 5 times 1 to the fourth minus 4 times 1 to the third, okay. And what do we get? 1, okay. All right, so I'm going to say the slope of the tangent line is 1, which is positive 1 over positive 1. So what is the slope of the normal line? So normal is perpendicular, so we do negative reciprocal. I take the fraction, I flip it, I change the sign. Okay, now for this one, it's not just a horizontal or just a vertical line. Now we actually have to go through the process of writing the equation of the line. They made this one a little complicated for you. They give you an x coordinate, but no y coordinate. So if we have an equation and we have an x coordinate, how do we find a y coordinate? You plug the x in. So take that x from the very beginning and plug it in to find the y coordinate. So y of 1 is 1 to the fifth minus 1 to the fourth plus 1. So what is the y coordinate? It's 1. Okay, so we have the point 1, 1. We found our slope. Our slope is negative 1. Okay, so we're going to use that point slope form of the equation. We're going to find a number equals our slope times x minus a number. Okay, so 1. Okay, what's our slope? Okay, what's our x number? Okay, so that's the answer for number 2. There's our slope. Okay, now let's go ahead. Say it again. Because that's the answer to that's the line that you're finding. But now we're going to go ahead and graph that line. Okay, so 1, 1 is right. Okay, slope of negative 1. Those are all the points that he could be sitting at. So he could be sitting at 1, 1, 2, 0, 0, 2, negative 1, 1, 2, 3. So it's 1, 2, 0, 0, 2, negative 1, 1, 1, 3. Okay. At some point, we will start to get clues that will help us narrow it down so we can figure out where these people are sitting. These people. Look at all the names. That is a class. Gauss. Leibniz. It's good. Okay, you can't do number 7. You can do number 7, but you have to do the limit definition. That's my hint to you. You have to do limit definition for this one because you don't know how to do it shortcut. Nah, you can do it. Forgot about the limit definition. I used to have students skip it, and then I realized you could actually do it. Okay. Okay. If you run into one that is particularly difficult, let me know. We'll do it together. Okay? Okay. So for number 4, what'd you get? We have line tangent to the curve. Tangent is always horizontal if it's 0, yes. Minus 5, 0. Okay, so what is the derivative? Okay, so y prime of 5 for the tangent line is negative 2 times 5 plus 10 plus 0. So x equals 5. Cantor is located on the line tangent to the curve at the point horizontal, y equals 0. So y equals 0, so Cantor is somewhere along here.
Oh
So he's at negative 2, 0, negative 1, 0, 0, 0, 1, 0, 2, 0. Yeah, so since the slope is 0, the tangent line is horizontal. And so it's y equals 0. You were doing vertical line, but it was because it was normal line before. Yeah. Yeah. Let's look it up. Because I recognize his name. All right. Number 8. Number 8 says the curve y equals ax squared plus bx plus c passes through the point 2, 4 and is tangent to the line y equals x plus 1. There's so much information in that first part. So as soon as it says the word tangent, what should we automatically think of? Derivative. So let's go ahead and do that. Y prime is 2ax plus b. Okay, so we found the derivative. All right? Now, they said to find the derivative at what point? It says through the point 0, 1, but it says it's tangent to the line at what point? 0, 1. Okay, so at 0, 1. It's tangent at 0, 1. Okay. It passes through the point 0, 4, but it's tangent at 0, 1. You guys see the difference there? Okay. So we're going to take the derivative. We're going to evaluate the derivative at an x-coordinate of 0. So I get 2a times 0 plus b, and what do I get? I just get b. Okay. So now, if I want to write my tangent line, I can use the point 0, 1, and I can use that my slope is b. Would you guys agree with that? Okay. So I've got y minus 1 equals b times x minus 0. So y minus 1 equals bx, b times 0 is just 0. Y equals bx plus 1. Okay, so do you see how I found the equation of my tangent line? Well, I guess I usually box my answers. I'm not going to box this. It's not my final answer. But do you see how what I just did is I'm comparing this with the tangent line they gave me? Now, if I compare this with the tangent line they gave me, they said the tangent line was y equals x plus 1. So what's the coefficient of the x here? And it's 1. So what does that mean b equals? B equals 1. Okay, so we just solved for one variable there. Whew. Okay, we got a little bit. We got a little something. We got something. We didn't get all of it, but we got something.
What did you do?
So in the problem, it said the tangent line was y equals x plus 1. So I said, and it was a tangent line at 0, 1. So because they said the word tangent, I did derivative. And because they said tangent at 0, 1, I went ahead and I plugged in 0. And then I just did what I like to do. It's like whenever line, I just take the point they told me used for the tangent line, and I just went, but they already told me what the answer was for the tangent line. So I took the information I had and I compared it to their answer. Now my b was in the spot of their slope, and since my b was in the spot of their slope and their slope was 1, that means b equals 1. So I solved for at least one of the letters that way. Okay, so we got b equals 1. That is part of the answer because A, B, and C you're supposed to solve for. Okay. Now it says ax squared plus bx plus c passes through the point 2, 4. That has nothing to do with the derivative. There's no wording there that says anything about a derivative. Okay. So that just means that we have an x coordinate of 2 and a y coordinate of 4. Let's go ahead and plug that in. X coordinate of 2, y coordinate of 4. So we're going to say, we're taking the curve y equals ax squared plus bx plus c. We're using 4 for y. We're using 1 for b, and we're using 2 for x. All right, and when we simplify that, what do we get? 4 equals 4a plus 2 plus c, okay? And then I'm just going to say 4a plus c equals 2. We comfortable with that? Okay. Now, if there is a point of tangency, right, there's the point that the tangent line touches, that point has to be on the curve, right? The point the tangent line touches is also a point on the curve. So what's another point we have on the curve? 0, 1. 0, 1 is another point we have on the curve. So what can we do with 0, 1? We can plug that in for x and y as well. So we used 0, 1 with our tangent line, but that 0, 1 on our tangent line has to be on the curve. That's how tangent lines work. They touch the curve. They touch the curve at the point where you are tangent. So that point that's on the tangent line, that's also on the curve. So we're going to plug that in as well. So we're going to do 1 equals a times 0 squared plus the 1 we got for b, and then the 0 we got for x plus c. So remember back to math 1, if you have two variables to solve for, you need two equations, right? So we have the first equation from the 2, 4, the second equation from the 0, 1. You guys see where I'm going with this? So basically what we're doing is we're creating a system of equations. This was a difficult problem, not for calculus. The calculus aspect of it was pretty simple. We heard the word tangent. In your brain, when you hear the word tangent, that should trigger derivative. Okay, so the word tangent triggered the things that needed to trigger. The hard part about this was hey, you're in calculus now, you should remember everything you've ever learned before. That was the hard part of this problem, okay? So this was not hard because of calculus, this was hard because it was remembering to go back to math 1. Okay, so what happens here? Yeah, 1 equals c. All right, so we got two of our numbers now. So what do we need to do to get a? 4a plus 1 equals 2. Plug in 1 in for c. 4a equals 1. What does a equal? A equals 1/4. Now, so we got the a, the b, and the c. Now, the nice thing about this one is that once you have that information, you can figure out exactly where Gauss sits. He sits at negative b minus c. Negative b minus c, and then 4 times a. So he sits at negative 2, 1. Exactly. So Gauss sits at negative b minus c, comma 4a. Yeah. So it told you that's where he sat, so I was just plugging my answers in. Comma. Yep, comma. 4a. Woo! Watch your remind later because I'll probably cut down this assignment. I probably won't have you finish it. Do you guys see why this was a good assignment though? Yeah. It's a good thinking assignment. Not approaching every problem the same. Every problem is slightly different. Did we all get number 7 done? We all got number 7? Okay. Yeah, pay attention to remind or check Canvas because I'll probably cut down the assignment. Yeah. Oh, yeah. Leave them. If you have your Larson pages that you could leave behind, leave them because I did not look at them at all. So 135, 146, if you are a spiral kid, come up in so I can look at them.